So state our null hypothesis is that mu equals 1. The alternative is that mu is greater than 1. Mu is the true average conductivity of the glass. When you put those data into a list, you find that the average is 1.118. If you rounded to 1.112, that's fine. Alpha level of 0.05, standard deviation of 0.0437. Good on this state? Then the plan, we're going to be doing a t-test. Random, up here it tells us it's randomly selected, right there. I, independence, is 11 less than or equal to 1/10 of the population? Yes, it is. And then for normal, because you have the data in there, and it doesn't tell you it's normal, and your sample size is less than 30, you need to look at a quick graph of it. I suggest box plots on your calculator, which Lindsay did. She graphed it. There are no outliers and no extreme skewness. So we can continue with our T procedure. Any questions on the plan? Then the do, so she drew the normal curve. It's got the center is 1 because we're assuming the null is true. And then she did give the general formula. The only thing, excuse me, that I would ask is that you also give the specific, I can't say that word, where our test statistic is t, our statistic is x bar, the parameter is mu, and then we're dividing by the standard deviation. Then she, oh man, I haven't typed mine in. Give me a second while I type them in really quick. 1.11, 1.07, 1.11, 1. All right, so then when you do the t-test, you're going to hit stat, go over to tests. It's number 2, and you can tell it to use the data because you have the data in the lists. Our null hypothesis is that mu is 1. My information is in list 1, so I'm going to use list 1. And then frequency should be 1. Not equal to, less than, greater than, so make sure you choose the last one. And then let's just calculate. So she got a slightly different p-value than me. Why did she get a different p-value? Rounding. Calculator actually used all the data versus not using data, using rounded statistics. Now, some of you might look at that and go, what, a p-value of 2? Make sure you read to the end where it's got that e with the negative thingy on there. What does that tell us? That we're going to move our decimal 6 to the left. So we get a really, 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 really small p-value. I think, if I remember correctly, if you tell it to draw, it'll actually just say p equals 0. Ooh, please draw. Okay, it is. I thought because I had that thing on there that it may not. Yeah, so if you hit draw, notice it just tells me p equals 0. If you hit draw and you get p equals 0, you should go back to calculate and get an actual decimal. You can move the decimal like she did, or you can write it in scientific notation. And then the conclusion, assuming H null is true, there is a really small chance of getting an X bar that is greater than or equal to 1.118 purely by chance. That gives us strong evidence against H null and is statistically significant at an alpha equals 0.05 level because our p-value is less than alpha. Therefore, we reject H null and conclude the alternative that the true average conductivity of the glass is greater than 1. Questions? I will leave that there for a second. Today we're going to do a significance test for paired data. Which is like pre-test, post-test type stuff. I don't know how that song ends. I would just keep doing it. But it does on the show. Where did they end it? Just whenever they want.
Maybe someone starts talking anything.
Really? It does. You're right, Seth. Bump, 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 bump. What are the bumps again?
I think it's.
You're right. You're right, though. It does. And Final Jeopardy, it's got the bump, 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 bump. All right, I'm going to move it. It's going back to Lindsay.
Okay.
All right, so like I said, we're going to look at paired data, which means pre-test, post-test type stuff. So, my husband, disclaimer, he did not give any students a smart pill. I just used his name in my example.
Is that a real thing? Smart pill?
Yeah. What's that? It's with, what's his face? It's a movie.
You mean the red pills and the blue pills?
No.
Oh, yeah, it's the Matrix.
No. I'll think of it. Don't worry. But it makes it so that, never mind.
Wait, what was the question?
There's a movie and it makes the guy not only really smart, but like he doesn't need to sleep. I want to say it's called it's something. I'll figure it out.
Unchained, unbroken.
No. But anyway, so my disclaimer is my husband never gave kids smart pills. Okay, I'm just pretending here.
Yeah.
So he believes that taking a smart pill minutes before a test will improve scores. He takes an SRS to 10 AP Psych students and uses them as part of an experiment. Each selected student will be part of the experiment for 2 tests. Before one of the tests, Mr. Bellsberg will give them a smart pill. Before the other test, he will give them a placebo. He will randomize order with which the treatments are given using a table of random digits, which I would have to teach him how to use. He would know the randomization part, but not how to use the table of random digits. So below, we have the test scores. So at the top, we just numbered the students 1 through 10. That is not part of the data. That's just so we could keep track of the score after a placebo and after a smart pill. Then we have the placebo test scores and the smart pill test scores. That sounded weird when I said it. Whatever, Nolan. All right, so what kind of design, this is going back to chapter 4, what kind of design was this experiment? Well, yes. Randomized. Blind, because they don't know whether they're getting the smart pill or the placebo. What?
You said 2 groups.
What kind of data did I tell you it was?
Paired.
remember the experiment name with the pear in it?
No.
Wait, hold on. It's in this one.
I thought we were talking about pears.
Blind. That's spelled differently.
Yeah, but not what I thought we were talking about when you're saying it. That's how I'm trying to get my hand on that smart pill, you know?
It's called average.
Oh.
I'm sure you'll take it in college.
Oh no, not if he hasn't partied by the time he graduates high school. It's called a matched pairs design.
Matched pairs design.
Thank you, Seth.
You didn't design.
Wait, are we gonna do like say red that? We're gonna have to identify that stuff.
I don't think I have it on there. No. All right. So, how would we do a significance test? The average what?
The average of, like,
Difference.
The average difference. Thank you, ma'am.
yeah.
So we can't put two sets of data in there and do a t-test. So what we have to do is we have to look at the difference between their test scores and then see if there is statistical significance for the difference. So we're going to do a significance test on their difference. Test on differences. Now, do we want to do placebo minus smart pill or smart pill minus placebo?
Placebo.
Why smart pill minus placebo, Annika?
Because they're all bigger than the placebo.
That and because
We should explain.
up in the paragraph, it says that Mr. Bellsberg believes taking a smart pill is going to improve scores. So that is going to be our alternative, that the smart pill is going to increase scores. So like Annika said, we're going to do smart pill minus placebo. So I'm going to draw lines in between each student so that hopefully it's a little more clear which student had which difference. And then our difference, we're going to do smart pill SP minus placebo PL. PL. So it's a little odd because the smart pill is on the bottom, so we're going to do subtraction upwards. So we're going to do 91 minus 89, which is 2. And then 80 minus 71, which is 9. 90 minus 93, that's negative 3. 97 minus 99, negative 2. 78 minus 68, 10. 89 minus 83, 91 minus 91, 0. 88 minus 83, 5. 85 minus 81, which is 4. And that's 12, right? 89, yeah, 12. So that's the list that we need to put into the calculator. So I'll give you a second to type it in. I'm going to type mine in as well. All right, we're going to state plan do conclude. Just as warning, those of you that write big, there's less room than usual, so write even smaller. Sorry. But with a table and then the two questions, there's not as much room in the box. All right, so state, what's our null hypothesis? What should we assume? That's going to be our alternative. So what should we assume?
The mean is the H1.
That they're equal. That there is no difference between taking a smart pill and a placebo. That, I know this is asking you to think way back, but last week when I first introduced significance test, I did say in the notes that sometimes your null hypothesis is a statement of no difference, which would be what we're saying here, that there is no difference between a placebo and a smart pill. Mr. Bellsberg believes that taking a smart pill is going to improve your test score. So smart pill minus placebo, if you do better with the smart pill, is the difference going to be positive or negative? Positive. So our alternative is that mu should be bigger than 0. If you did placebo minus smart pill, you could do this. It's just your alternative would be that mu is less than 0. Then we're going to define mu. So mu is the true average difference in test scores. And then what else do we need to put in our state? Standard deviation and our mean, x bar, s sub x, and alpha. So what is alpha? That one we don't need the calculator for. 0.05. And then x bar and s sub x we'll use the calculator to find. So we have our list. Mine is list 1. So stat, calc, 1 bar stats. List 1, frequency list should be empty. And then you're going to calculate. And we get an average of 4.3 and S sub x of 5.1. Any questions on the state? All right, plan. What's our calculator function? T-test. And then what are our conditions? Random, normal, independent. Thank you. Random. Tells us, oh, there it is. I was like, I know I put it in there. Up here in the top right, tells us he took an SRS of 10 students. Normal. Does it say that the test scores follow a normal distribution? No?
No.
Is our sample size greater than 30? So what do we do? Box plot of our data. So we're going to do second y equals. Make sure you choose the first box plot. So turn it on. That one, list 1. And then zoom 9 so it picks a good window. Do I have outliers? Do I have skewness?
No.
No. So we're good. So we graphed it. No outliers, no skewness. And then normal, or excuse me, that was normal. Independent, sorry. I'm gonna as we check independent, I'm going to edit my paragraph up here. So independent is that the sample size is less than or equal to 1/10 of the population. The sample was 10, so that means the population has to be at least 100, which he doesn't have 100 students in AP Psych, so let's just get rid of the AP Psych part and just say he did it to 10 students.
It could have been like all of the students ever. That's, yeah.
Sure. All right, any questions on the plan?
Don't we have to include the T equals blah, blah, blah?
That's in the do.
Oh.
All right, so do,
Will we get it wrong on a test if we put that wrong there?
as long as it's there, we're good. All right, so we're going to draw our normal curve. Well, what about that statement was wrong?
It's a standard one.
It's not normal. It looks normal, but it's technically a T-curve. Remember, because it's means it's a T-distribution. And what's our degrees of freedom?
9.
9.
Wait, why is this one a T curve and the warm-up?
Because I just overlooked that fact from the warm-up. Sorry, that was my bad. I was just happy somebody had the warm-up all done. All right, so what's going to be at the center of our curve?
0.
0. And then standard deviation
5.1.
divided by
10.
square root of 10.
It should be true.
I don't know. Square root 1.61. Thank you, sir. How about 1.6? So you're both right. And then it makes my mental addition subtraction easier for me because there's less decimals to keep track of. So that's 1.6, that's 3.2, and that'd be 4.8. Negative 1.6, negative 3.2, and negative 4.8. And then, like Annika said, this is where we need to have our actual, like, T equals. But we also need the general formula, which is that our, oops, sorry, I forgot the word test. Our test statistic comes from our statistic minus our parameter divided by our standard deviation. We're working with means, so our test statistic is T. We have x bar minus mu divided by s sub x divided by the square root of n. X bar is 4.3, mu is 0, and then our standard deviation s sub x divided by n is 1.6. 4.3, bless you, divided by 1.6, we get t equals 2.6875. And then we're going to use the calculator to get the p-value. Oh, and I almost forgot to shade. 4.3 is here-ish, and we're looking at greater than. Any questions so far? Alrighty, I'm going to put my calculator in the way. We're going to t-test, so stat, go over to test, number 2. Data, because you have it in a list. You need to change the null to 0. I have it in list 1. and we're still working with greater than, so make sure that third one is highlighted. Calculator draw. Calculator draw. Oh man, I forgot to get rid of my box plot. Sorry. Alright, so it tells us down in the corner that T is 2.6662. So slightly different than what I got because of rounding. And then our P is 0.0129. Any questions? No questions? All right, conclude. Conclude. How do we start the conclusion? Assuming H null is true. Bye, Gabe.
Wish me luck.
Good luck.
I love you, baby.
Assuming H null is true. If I was Gabe, I'd be very angry. He said he loves you, and you said bye, bro. Like, that's not the same thing.
Same thing.
But
It doesn't have to be said, you know?
oh,
Because he
okay.
just knows. He knows.
So we're assuming that the mu equals 0. There is a 0.0129 probability. I'm going to abbreviate probability of getting x bar greater than or equal to 4.3 purely by chance. Any questions on the first sentence?
No.
Great. Strong or weak evidence?
Wait, can you repeat that?
Strong evidence for supporting.
Strong evidence against H null.
Against H null.
And is
Yeah.
statistically significant So are we going to reject or fail to reject? Nolan, reject or fail?
Fail.
No.
Reject.
Reject. Therefore, we reject H null and conclude HA that the smart pill improves test scores. Questions? All right, we're gonna do another one. We're gonna go a little quicker this time. Hey, Jack.
Hello.
How's it going?
Good. How are you?
I'm doing pretty good.
Just a little bird.
Dun 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 dun. Thank you.
Yep.
That's scary.
All right. So this time, our situation is that the Medford School District is interested in adopting new curriculum. To see if the new curriculum is effective, the district randomly selects 500 students and compares their scores on a standardized test after the curriculum change with their scores on the same test before the curriculum change. The mean improvement was X bar D, that D stands for difference because they looked at the difference in the scores, of 0.9 with a standard deviation of 12. Does the data suggest that the new curriculum is working? We're going to state, plan, do, conclude. So what's our null?
U equals 0.9.
No, we would assume there is no difference. We want to see if there is a difference. So our null is that there is no difference or mu equals 0. The alternative, so the mean improvement was 0.9, so we're going to say that the alternative is that mu is greater than 0, that the new curriculum does improve test scores. Mu is the true average difference in the test scores. Now this time we don't have data. We just are given the statistics. So what is our X bar? 0.9. That's given right there. What's our S sub X?
12.
12. That's given right there. And then what's our alpha?
0.05.
Thank you, sir. 0.05. Any questions? All right, plan. What's the calculator function? T-test. What are the conditions? Thank you, ma'am. Random, normal, independent. How do we know it's random? Randomly select 500 students, so we'll just quote randomly. Normal. How do we know it's normal?
Mu is greater than 30.
I'm sorry, say it again.
Mu is greater than 30. Or the sample size is greater than 30.
Our sample size is greater than or equal to 30. Thank you, ma'am. It says they picked 500 students, which is greater than or equal to 30. So the central limit theorem applies, and our sampling distribution is going to be normal. Independent. So our sample size is 500. Now it doesn't specify like a school. So are there more than 5,000 students in the Medford School District?
Yes.
Yeah. So we can say independence is met. Any questions on the plan? All right, do the do. You know, YouTube might copyright me if I say that too much, huh? Do the do.
Bianca would say, you just said you do.
All right.
She's been silenced.
I have been. I'm speechless. All right, so what is our degrees of freedom on this curve? 499. What's at the center? Standard deviation?
12 over the square root of 500.
Thank you, ma'am. 12 divided by the square root of 500, which, anybody happen to have the decimal for me yet? Please, and thank you.
0.5367.
0.53.
Yeah.
Okay.
Or, no,
Well,
0.54.
0.54. Okay. So that's 0.54. So that's 1.08. 58, 1.62. And then these are nice because going backwards is just the negatives. I don't have to use brain power to figure them out. General formula. Keep forgetting the test on these, sorry. Test statistic is your statistic minus your parameter divided by your standard deviation. Specifically for this one, that's going to be t comes from x bar minus mu divided by s sub x over the square root of n. X bar is 0.9, mu is 0, s sub x divided by the square root of n is 0.54. 0.9 divided by 0.54, oops, not 2.54, 0.54, is 1.67. And then we'll use the calculator to get our P. Our x bar was 0.9, which is here-ish. And we're looking at greater than 0.9. Everybody good? Did you get the p-value for me, Nolan?
It's drawing, I'll get it.
Okay.
Takes
Do 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 do.
Alright, 0.0471.
Thank you, sir.
Yep.
Everybody agree with that? All right, now I'm going to be lazy and we're going to do what I call a bare bones conclusion. Is P less than or greater than or equal to alpha?
Yes.
Less than. So if P is less than alpha,
Strong.
we have strong evidence. Is it statistically significant or no?
Yes.
Are we going to reject or fail to reject?
Reject.
So, the only thing I'm going to add, we conclude the alternative, which says that the new curriculum is better, right? Yeah, I want to make sure we have enough time to get to the next part because it's important, so I didn't want to spend all the time writing. So, if you flip it over, it says we have two potential problems with our results from the previous problem. One, we're comparing new scores to the scores before the new curriculum. So we would expect an increase no matter what the curriculum was, because why? Let's say they ran this experiment on you. So last year you had old curriculum. At the end of the year, they gave you a standardized test. This year there was new curriculum. At the end of this year, they give you the same test. Why would we expect your test scores to be higher this year?
Because
older.
you've had more practice.
You've had more practice, you've seen the material more, right? So there's issues with that result because you guys had more practice, more exposure, more schooling. So we would expect that a year later you're just going to get better scores for those reasons. The other issue is, even though we found the data to be statistically significant, we have to think about whether it's practically significant or not. What do you think I mean by that?
It's not actually helpful to what it actually is.
Yes. So did I specify what standardized test it was? So if I tell you that the standardized test was the SAT, how many of you have taken the SAT? How many points is it out of? It's out of 1,600. I couldn't remember. It was 1,600, and then for a while it was 2,400, and then it's gone back to 1,600, and my pen has officially died. So our test is the SAT. You can get 1,600 points. Is an improvement of 0.9 points really that important?
No.
No.
Aww, so sweet.
Sorry, I started to write statistically significant. It's not practically significant. It really doesn't help us that much. So should the district spend all that money on a new curriculum when it really didn't change much in the big scheme of things? No. So this is another place where statistics can lie. The data actually was statistically significant, but we have to think about it in the actual big picture. I can promise you'll have a question about statistically significant versus practically significant on your test.
So this is a type 2 error?
No. We made the correct decision based on the math. It just, a 0.9 increase is not really practical when you're taking a test out of 1,600 points. So it would not, even though it's statistically significant, the increase is so little that the district really shouldn't spend money on the new curriculum. Did you have a question?
Well, I was going to say, so it's not only significant, but not, but when you apply it to the actual situation that it's testing for, it's not as practical.
All right, can I move it up?
Yeah.
Mr. Black believes that playing music during class will improve test scores. He informs his class of his idea and then begins playing music during class. He tells the class that he will measure the results with the chapter test at the end of the chapter. At the end of the chapter, he finds the test scores have improved on average by 4.3%. This is statistically significant with a p-value of 0.03. What are two problems with Mr. Black's experiment? He told them. What is that called?
Bias.
Yes, but it's got an actual name. Oh, come on. Who's in AP Psych this year?
I was in last year.
Okay. Remember, my husband has you watch people without telling them and then watch people with telling them. What's that called?
Hey,
Did you pass?
I did pass.
Yeah,
the 4.
she's like, I don't need it anymore.
Exactly. I got a 4 on the AP exam. I'm good. I'm done.
It's called the Hawthorne effect.
How were we supposed to guess that? Like, come on.
Well, at my I should have been able to.
Guys, the information leaves my brain. It wasn't
It's not good.
Miss Whittle, how much information did you retain from high school?
All of it.
I don't believe
Every
that.
single thing.
You made me LOL.
I know. That just registered in my head what you said. I retained a lot. Quite a
Well,
bit.
then you're 1 in a million. Because
Thank
honestly,
you.
nobody
I am
retains
1 in a
information.
million. I don't know if that's the right effect. I never retained that one.
So it's not even
Never
right.
have. I'm pretty sure it's E, but I don't know. All right, any other? Well, I'm sure there are lots of other ones, but what's another issue with Mr. Black's experiment?
No,
There was
like no control group. No random.
No, there was a control group, their first test score.
No randomization.
Yeah, I suppose you could say that. Yeah. I was hoping that maybe you referred one of these up here. They're taking the next chapter test. Well, you guys just proved me wrong. Everything leaves your head once you've learned it. Once you've taken the test and passed, you're like, nope. So never mind. My thought was if it's the next chapter, their test scores should go up because
No, not at all.
Okay,
Well, it's a
okay.
different chapter.
It's science. It's pretty like built on itself, right? No?
No.
I mean,
Really?
No, different chapter.
Okay, then we'll write down on it, guys. No randomization, because there is no randomization.
yeah, Mr. Black made me learn every constellation in the sky in the first month, and then after that wanted me to do rocket science. So
Yeah, that's
They don't
yeah,
really
But
go
you
into
can
very-
still name some of the constellations, maybe not all.
yeah, no, not all.
I can name quite a few of the constellations still.
Miss Whittle, what's your geography?
What?
What's your geography?
Pretty good.
Really?
I can name all the states in alphabetical order.
I can
Go, do it now.
Any of the states in the
Alabama,
middle?
Alaska.
No, that's not fair.
Sing the song.
that song.
Yeah, exactly.
Honestly,
Sing the
for
song.
me.
Take that back. Redact that.
I know most of the. I did. I didn't even make it through the A's.
No,
Okay.
no, absolutely.
I heard enough.
I also know most of my state capitals because I learned them in elementary school and
Yeah, but I
remember 'em.
forgot all of that. I don't know any of the middle states.
Good job.
I don't know any of the middle states. Any of the middle ones? I don't know.
I
also
could
forget most of
probably
the
I know
name,
it does
like if
scares
you
me, but-
gave me a picture, I could probably name most of them correct.
And
Maybe
also,
not
Maybe
100.
Is Kansas a state or like a town?
Yes,
Yes. She said yes.
because
Why'd you
it's
get it?
both.
Consider a town.
Yes,
It
it's
is?
both. It's both. There is Kansas State, and then there's Kansas City, Missouri.
There is
Oh,
Kansas City. But
You couldn't have told me there was Missouri. I would know.
All right.
Alright, kids, I don't know that.
It's a state. What do you do there? My grandparents live there. Oh.
Well, it's Wednesday, so it's 27,
Oh, so it's a series from Lego.
which is like a million, which is why
So
I
I
tried to not push
Right, max level.
Will you all shut me down on this? I know most of my capitals too.
I know very good.
That's like, take chess